Welcome to The Explainer. Today, we're going to do a deep dive into a really critical security feature in Cisco's SD-WAN, the SSL and TLS Proxy. You know, if you've ever found yourself asking, how in the world do I inspect traffic that's specifically designed not to be inspected? Well, you've come to the right place. So here's how we're going to break it all down. First, we'll talk about the fundamental problem this whole thing solves, what we call the encryption blind spot. Then we'll get into the nitty-gritty of the TLS proxy itself. After that, we'll walk through one of the most important decisions you'll have to make, choosing your certificate authority. From there, we'll build a decryption policy from the ground up. And finally, we'll wrap up with the key things you absolutely need to be aware of before you even think about deploying this. Okay, so let's jump right in. To really get why this TLS proxy feature is such a big deal, we've got to first talk about a massive problem that pretty much keeps every network security pro up at night. And this question right here, this is the core of the whole dilemma. Encryption is fantastic, right? We need it for privacy, for secure transactions, but it's a double-edged sword. That very same encryption can become a perfect hiding spot for attackers. Malware, command and control traffic, data exfiltration, all that nasty stuff can be wrapped up in a TLS tunnel, cruising right past your firewalls and security tools completely unseen. So what's the solution? How do we fix this? Well, Cisco's answer inside the SD-WAN fabric is the TLS proxy. The best way to think about it is as a trusted, super smart security checkpoint that's built to shine a light on all that dark, encrypted traffic. So what is it really? Well, it's basically a sanctioned man in the middle. Now, I know that phrase can sound a little scary, but stick with me. It sits right between your user's computer and the server they're trying to reach. It intercepts the encrypted session, carefully unwraps it, and lets your security tools like Cisco's Unified Threat Defense, or UTD, take a look inside. Once it gets the all clear, it just rewraps the traffic in a brand new encrypted session and sends it on its way. It's seamless to the user and the server, but it gives you that crucial visibility. And check out this diagram. It gives you a really clean, high-level look at how the traffic flows. You see the traffic comes in, the connection gets set up, but then it hits that central decision point. And right there, the proxy takes a look at the policy you've created to decide what to do next. It's not just blindly decrypting everything, it's being intelligent about it. Okay, let's really unpack this step by step. It all kicks off with a standard TCP connection. Then, in step 2, the client sends out its client hello packet. The proxy snags that packet and passes it over to the UTD engine, and that brings us to the key moment, step 3. The UTD engine looks at your policy and makes a call. Does it drop the traffic? Does it let it pass through untouched? Or does it send it on to step 4 for the full decryption and inspection process? It's all about that policy-based decision. Okay, so the proxy knows how to make a decision. But you know what? None of that matters if it can't establish trust. And that brings us to what is honestly the most critical foundational decision you are going to make when you set all of this up: your certificate authority strategy. And let me be super clear here. This is an absolute non-negotiable deal breaker. For this whole magic trick to work, the proxy has to pretend to be whatever website the user is going to. It does that by creating a fake certificate on the fly. But if the authority that signs that certificate isn't trusted by the user's computer, well, you're going to have a bad time. You'll get security warnings everywhere, applications will break, and your help desk is going to light up like a Christmas tree. Trust is everything. Now, this diagram does a great job of laying out the 4 main ways you can tackle this trust problem. You can see on the far left, you've got the simplest approach, where vManage just handles everything itself. And as you move to the right, the models get more integrated with your existing enterprise infrastructure. So let's dig into the pros and cons of each one. Think of this table as your decision-making guide. First up, vManage as a root CA. This is your easy button, right? Super low overhead. If you don't have an internal CA already, this is probably your go-to. Next, vManage as an intermediate CA. This is a nice security middle ground. Your main enterprise CA signs off on vManage's authority, which kind of limits the blast radius if something ever went wrong. Third, the full enterprise CA model. This is for all you control freaks out there. It's a lot of manual work, but it means your central security team keeps the keys to the kingdom. And finally, my personal favorite, enterprise CA with SCEP. This is the best of both worlds. You get that centralized control, but with all the beautiful automation that SCEP brings to the table. For most big companies, this is the sweet spot. All right, so you've picked your CA model, you've got your foundation of trust all sorted out. Now what? Well, now we get to build the brains of the whole operation, the decryption policy itself. This is where we define the rules of engagement. And here we go. This is a look at the actual policy builder inside vManage. This is where the magic happens. You can see on the left, you've got all your matching criteria, things like source and destination IP, or even URL categories. Then on the right, you pick the action. This lets you get super granular. You can say things like, hey, decrypt everything going to social media sites, but whatever you do, do not touch traffic going to banking sites. So for any rule you make, you've basically got three choices. Decrypt is the obvious one, right? Full inspection. But no decrypt is pretty cool too. It won't look inside the traffic, but it'll still check to make sure the server's certificate is valid, which is a nice little security win. And pass-through just means, hey, ignore this completely. Then you've got these global settings. You can block connections to sites with bad certs, and this is a big one, the failure mode. If the proxy service itself has a problem, what do? Do you feel closed, blocking the traffic to prioritize security, or do you feel open, letting it go through uninspected to prioritize keeping users online? That's a major business decision right there. Okay, hold on. Before you get all excited and start deploying this everywhere, we need to talk about some really important prerequisites and limitations. Seriously, this is not a feature you can just flip on without some careful planning. First, let's talk prerequisites. The big one is symmetric traffic flow. That just means the traffic has to go out and come back through the same device. It's a must-have. Now, for the limitations, and you really need to pay attention to these. First off, this thing is resource hungry, so make sure your hardware is up to spec. But the really big one, the one you have to plan around, is that it only supports up to TLS version 1.2. It just flat out doesn't support the newer, more secure TLS 1.3. On top of that, there's no support for IPv6 traffic and no support for client-side certificate authentication. These aren't necessarily showstoppers, but you have to know about them and design your network accordingly. Okay, for all my fellow network engineers out there, this one's for you. When things inevitably break or just don't work the way you expect, the command line interface is going to be your best friend. These are the show commands you're going to live and die by. You'll use them to check your config, see what the UTD engine is doing, and verify all the underlying services are running. Trust me, get familiar with these commands. They will save you a world of hurt during troubleshooting. And that really brings us to the final big picture question here. A tool like this TLS Proxy, it gives us incredible visibility. It lets us apply our entire security stack to traffic that used to be a complete black box. But with all that power comes a huge responsibility, right? It forces us as engineers and as organizations to have some very serious conversations and create crystal clear policies about what we inspect, why we inspect it, and what we choose to leave alone. The technology gives you the capability, but the wisdom of how to use it, that's all on you.